You ever just stop and think about how much we rely on technology these days? I mean, it's like we're living in a sci-fi movie with all this cutting-edge tech. But are we really as secure as we think we are?
That's a great question.
That's what we're diving into today.
Yeah.
A whole stack of brand new research papers from the ARC company.
All published today.
January 16th, 2025.
Yeah.
All about the latest in cybersecurity and privacy.
Really fascinating stuff.
From AI, that can be used for good or bad, to quantum computing that's like changing the whole game.
Definitely changing the rules.
These papers give us a peek into the future of digital security and what it means for all of us.
I think it's going to be a wild ride.
Yeah. Let's jump right in. There's this paper, Dynaseal, Dynamically Constrained Bearer Tokens for Controlling LLM Access from Edge Devices. Okay, so LLMs, these large language models.
Oh, yeah, those are
they're everywhere now.
Huge right now.
But accessing them from like our phones and smart devices brings up a whole new set of security concerns.
For sure. Right. It's not like installing software and forgetting about it.
Right.
These LLMs, they're always evolving.
Constantly.
And we need ways to like really control how they're accessed and used, especially from those less secure edge devices.
Yeah, because those are way less secure.
Definitely.
So what's wrong with the way we're doing it now?
Well, a lot of systems right now, they use these things called bearer tokens for authentication.
Okay.
You can think of it like a key card.
Right.
Gives you access to the LLM. Problem is, these keys are often static.
Meaning?
They don't change.
Oh.
So if someone gets a hold of your key card, they've got full access. Not ideal, especially with these powerful AI models we're talking about.
Right. So it's like I leave my spare key under the doormat and just hope for the best.
Exactly.
Not the best security system.
And that's where this Dynaseal comes in.
Okay.
It brings in this idea of dynamically constrained bearer tokens. The dynamic part is key here.
Okay.
These tokens can be set up with specific constraints by the server, where the LLM lives. So you can control which functions a user can access, how often they can make requests, even from which devices.
So this user gets like a custom key card.
Exactly.
And it only unlocks certain doors, not the whole building.
Precisely.
Yes.
It's much better from a security standpoint.
Way better.
Definitely.
Okay, that makes a lot more sense.
It's really rethinking security with these AI models that are so powerful and easy to get to.
Totally. Speaking of rethinking things, there's another paper called A Refreshment Stirred, Not Shaken. Invariant Preserving Deployments of Differential Privacy for the US Census.
Okay.
Big title.
Yeah.
So it's tackling this challenge of protecting privacy in the US Census. Yeah. Especially since they started using differential privacy in 2020. I gotta admit, differential privacy.
Yeah.
Sounds kind of intimidating.
It's a mouthful.
Can you break that down for me?
So differential privacy is basically adding a bit of noise to the data. Carefully calculated noise, of course. It's kind of like whispering your answers instead of shouting them on a survey.
Right.
It makes it harder to identify individuals while still letting researchers get accurate results on the whole population.
So it's like you're blurring the lines just enough
to
protect individual privacy.
Right.
But this paper looks at different methods of differential privacy. Why is that so important?
Because it turns out there's more than one way to add that noise. The 2020 census used a new method called the TopDown Algorithm, TDA.
Okay.
And this paper compares it to the older one, the Permutation Swapping Algorithm, or PSA, they used back in 2010.
Okay.
Both of them are trying to preserve these statistical properties invariance.
Invariance?
Yeah, they stay the same even after you add the noise. They're like the key features of the data we want to keep intact.
So it's like making sure the music still sounds good even after you've turned down the volume.
Exactly. But what's interesting is that TDA and PSA, they keep different types of invariance.
Oh, so there are trade-offs.
Yeah, trade-offs between privacy loss and how useful the data is.
Okay.
Like one might be better at protecting certain types of information, while the other one gives more accurate stats for something else.
So it's a constant balancing act.
Yeah, always a balancing act.
Sounds like there's no easy answer.
But when it comes to data privacy, it's all about choosing the right tool for the job and understanding what each method can and can't do.
Right. This next paper, when I read this one, it kind of gave me chills. Tag and Tab. Keyword-based pre-training data leakage of LLMs via probabilistic analysis.
Uh-oh, that sounds intense.
It talks about how all the data, these huge data sets that are used to train LLMs, that data could be hiding secrets.
Yeah, they're trained on mountains of data.
And someone could uncover those secrets.
It is a bit of a sobering thought, right?
It is.
These LLMs.
That write poems and code.
Like magic.
Yeah.
It could be anything in that data. Sensitive personal information, copyrighted stuff.
Right. So even if companies are trying to be super careful about what they use to train these models, there's still a chance that someone could figure out what's in there.
That's the worry, and this paper introduces this technique called tag and tab.
Keg and tab.
Yeah, it uses keywords and probability analysis to figure out if specific data was used in the training process.
Okay, so it's like digital detective work.
Exactly.
Looking at the output of the LLM and piecing together clues about the data it was trained on.
That's a good way to put it. It's like a blacklight, revealing hidden information.
And the scary part is,
Oh, yeah.
tag and tab is way more accurate than previous methods.
Much more accurate.
And it even understands that some words are more important than others, more revealing.
Absolutely.
This feels like a huge wake-up call.
Definitely a wake-up call.
If our personal information or like copyrighted stuff can be pulled out of LLMs,
Yeah.
the implications are huge.
We need better ways to protect the data used to train these models.
We definitely do.
This paper is highlighting a really critical area of research, something we need to pay way more attention to. We've got to figure out how to train these LLMs without risking people's privacy and security.
Okay, let's shift gears a bit and talk about blockchain tech.
Okay, sure.
There's this paper, Formal Model-Guided Conformance Testing for Blockchain Interoperability.
Okay.
It's about this challenge of making sure that different implementations of a blockchain protocol, that they actually work with each other.
It's like building a house with different teams, right?
Yeah.
If they're not all using the same blueprints, you're going to have problems.
Walls that don't line up.
Exactly. Or even worse.
Oh, no.
Yeah, like a structurally unsound building.
And in the blockchain world, that would be like a major security flaw.
Exactly. If different clients implementing the same blockchain protocol,
Yeah.
if they're not perfectly in sync,
Right.
it can cause all sorts of issues. Transaction errors, even security exploits.
So this paper is about making sure everyone's on the same page.
Exactly. They're using this formal model-guided conformance testing. It's basically using math models and simulators to make sure each client implementation sticks to the protocol perfectly.
So it's like sending in a building inspector
Exactly.
to make sure everything is up to code before anyone moves in.
That's a great analogy. It's really about building trust and security in the blockchain world. Because the whole point of blockchain is to have this decentralized, tamper-proof system, right? But that only works if everybody's playing by the same rules.
Okay, let's talk about something I think everyone can relate to, network security.
Okay.
So this paper, Multi-View Correlation-Aware Network Traffic Detection with Hypergraphs, a dual contrastive proxy task learning approach. It's a mouthful, I know.
It is a long one.
But it shows just how complex and diverse network traffic has become these days.
Yeah, it's not just emails and browsing anymore.
Right.
It's a jungle out there.
It is.
And we need new ways to, like, see the threats, the anomalies, and stay safe.
So how does this paper propose we do that?
They introduced this framework called FlowID. It uses hypergraphs to analyze network traffic.
Hypergraphs.
Yeah, they're like graphs, but supercharged.
Okay.
They can capture all these relationships between tons of data points at the same time.
So you see the whole web of connections, not just individual points.
Precisely. That's super important for understanding what's going on, the intent behind the activity.
Right.
FlowID can spot these subtle patterns, correlations that traditional methods miss.
It's like having a security camera that not only sees what's happening, but can understand why it's happening.
Perfect analogy.
Okay, that's pretty powerful.
And it makes FlowID way more accurate at detecting anomalies. It can tell the difference between good traffic and bad traffic, even if the bad traffic is trying to blend in.
That sounds like a game changer for security. Yeah. And speaking of games, it seems like the attackers are upping their game as well. This next paper, Multilingual Email Phishing Attacks Detection, using OSINT and machine learning.
Yeah, phishing is unfortunately still a huge threat.
Oh, definitely.
And it's getting more sophisticated.
How so?
Well, one way is they're going multilingual.
So, not just those Nigerian prince emails anymore.
Not anymore, no.
It's more than that.
They're using all sorts of languages to target wider audiences and make their scams more believable.
Okay.
It makes it harder to detect them using the old ways that focus on language-specific cues.
Yeah, that makes sense.
So this paper combines the power of open source intelligence, OSINT,
Okay.
with machine learning.
Like digital detective work.
Exactly. They use tools like Nmap and the Harvester to gather information about websites and email domains, things like IP addresses, open ports, the history of the domain name.
So it's like giving the machine learning model a background check on the sender
Exactly.
before it decides if the email is legit or not.
You got it.
Okay, so what were the results?
Pretty impressive. They found that using this OSINT data along with a machine learning model called Random Forest, it really boosted the accuracy of detecting phishing emails, even across different languages.
That's great.
Yeah.
But it also shows how we need to constantly adapt, to stay ahead of these evolving threats.
Absolutely. Always evolving.
Let's move on to something really relevant in the crypto world.
Okay.
Smart contract security.
Right.
This paper, Virite, a profit-centric smart contract fuzzer for detecting and exploiting profitable vulnerabilities.
That's a mouthful. It is. It is.
But an important topic,
it is.
smart contracts are agreements written in code, right?
Right.
Yeah, they're used for all sorts of things, from decentralized finance to managing digital assets.
Right.
But if there's a flaw in the code,
Uh-oh.
it can be exploited, and that can lead to big financial losses.
So they're like digital vaults holding a ton of value.
You need to make sure they're unbreakable.
Yeah, so no flaws in that code.
Right, and that's where fuzzing comes in.
Fuzzing.
It's a testing technique where you essentially bombard the code with random inputs just to see if you can break it.
Sounds a little chaotic.
It can be, but it's really good at finding vulnerabilities.
And this paper introduces this new fuzzing framework called Virite.
Verities.
And it focuses on what they call profitable vulnerabilities.
Profitable vulnerabilities. What does that even mean?
The vulnerabilities that can be exploited to make money.
Ah, okay.
So Virite doesn't just find them, it figures out how to maximize the profit from exploiting them.
So it's like a security consultant
Yeah.
who not only finds the flaws, but also tells you exactly how much money you could lose if you don't fix them?
Exactly. It gives developers crucial information so they can prioritize which vulnerabilities to fix first.
Right, the ones that are going to cost them the most money.
Exactly.
Let's switch gears a bit and talk about vulnerability research, especially for all those different computing environments out there, like IoT and embedded systems.
Yeah, good topic.
There's this paper, CVAB Sheet, a curated data set for binary static code analysis.
Okay.
It's about how we don't have enough comprehensive data sets for these systems.
It's a big problem.
Why is that such a problem?
Well, it's because there are so many different kinds of devices.
Right.
IoT is everything from smart refrigerators to connected cars.
Yeah, it's everywhere.
And they all run on different hardware and software.
Right, totally different from your typical computer.
Right. It's like the Wild West out there.
It is.
And that makes it hard to develop and test security tools.
Because there's no standard.
Exactly. You need data that reflects all that diversity.
To know that your tools are actually working.
Exactly. And that's where the Savobinary Sheet comes in.
Okay.
It's a new database with over 1,000 CV entries, with pre-built binaries for all sorts of architectures and scenarios.
So it's like a virtual testing lab
Exactly.
for IoT security,
Right.
with every device and configuration you could need.
A great analogy. This database is a really valuable tool for anyone developing security tools for these complex systems.
So it's a big step towards making sure the whole IoT revolution doesn't turn into a security nightmare.
Exactly. Got to stay ahead of the game.
Okay. Let's dive into the world of graph APIs. There's a paper called Automated Broken Access Control Detection for Graph APIs via Taint Analysis.
Interesting.
So it's about these security challenges with graph APIs. They're being used more and more for accessing and manipulating data that's kind of organized like a network.
Yeah, graph APIs are really powerful. They let you interact with data that's structured like a social network or a map even. But with that power comes risks.
So what's the biggest concern with graph APIs?
I'd say one of the biggest risks is broken access control.
Broken access control.
Basically, it means someone could access data they shouldn't be able to.
So they'd exploit a flaw in the API
Right?
and steal information, even though they shouldn't have access to it.
That's the worry.
That's a big worry.
And this paper presents a new method for detecting these vulnerabilities using something called taint analysis.
Taint analysis.
It's like following a trail of breadcrumbs
Okay.
to see how data flows through the API.
So you're tracing the data
Yeah.
to see if there are any weak spots.
Exactly, where someone could get in. And they've automated this process, which is huge, because manually doing this would be a nightmare,
Yeah, makes sense.
especially with these complex APIs.
Right, right. Now, this next paper is really intriguing.
Okay, I'm intrigued.
It's called Trusted Machine Learning Models Unlock Private Inference.
Okay,
It suggests a completely new way to think about data privacy.
that's great. A new approach.
Instead of using cryptography to protect data,
Right, the traditional way.
they're saying why not use machine learning models as trusted third parties?
That's a really interesting idea.
Machine learning models as trusted parties? I mean, how would that even work?
It is pretty mind-bending.
Yeah.
The idea is that these models can do these complex calculations on data without revealing the raw data itself. It's like a chef who can tell you exactly what's in a dish without ever seeing the recipe.
Wow, that's a powerful analogy.
Right.
But it brings up some big questions. Can we really trust AI with our sensitive information?
It's a valid concern, and it's something researchers are definitely looking into. But the potential benefits are huge. This could unlock a whole new world of secure computing, stuff we can't even do with cryptography right now.
Right, and that let us analyze and share data in ways that we never thought possible.
Exactly. It's a whole new era of data privacy, where AI is both the problem and the solution.
It's both.
Yeah, both sides of the coin.
Okay, speaking of new eras, this next paper is about the threat of quantum computing.
Right, a big one.
Secure composition of quantum key distribution and symmetric key encryption. It's all about creating new security measures in a world where quantum computers could crack our current encryption methods.
Yeah, quantum computers are next-level computing power, right?
They are. Exponentially faster, more powerful than anything we have now.
Right, and the worry is they could be used to crack the encryption that protects everything.
Our online banking?
Everything.
Everything. Our private messages, everything.
So what's the solution? How do we protect ourselves in this post-quantum world?
This paper focuses on quantum key distribution, or QKD.
It's a way to share secret keys using quantum mechanics.
Okay, you lost me a little bit at quantum mechanics.
Oh, no, it's complicated. Think of it this way. You're sending a message in invisible ink. If anyone tries to read it, the ink smudges, so you know someone was snooping.
I like that.
That's kind of what QKD does.
Oh?
It uses light particles to send keys in a way that any eavesdropping would be instantly detected.
So it's like an alarm system that goes off if anyone tries to look at the key.
Exactly. And the paper goes further, talking about combining QKD with regular encryption to make a really robust system, even against those quantum attackers.
This sounds like a really important step towards making sure we're secure in this quantum era.
Definitely an important step.
Okay, now this next paper is a bit of a surprise. It involves ChatGPT.
ChatGPT, huh?
Yeah, the AI everyone's talking about. The paper is exploring ChatGPT for face presentation attack detection.
Interesting.
It shows how these large language models are being used for things we never expected,
In all sorts of ways, yeah.
even in cybersecurity.
I mean, who would have thought?
Wait, ChatGPT? The same one that can write poems and code.
That's the
What
one.
does that have to do with security?
Well, this paper looks at how it can be used for face presentation attack detection, or PAD.
Okay.
Basically, it's about telling if someone is trying to fool a facial recognition system with a photo or a mask.
Okay.
And get this, the paper shows that ChatGPT, specifically the GPT-4o model, it actually beats some of the current POD models, even the ones that companies are using.
Wow, that's amazing. I had no idea ChatGPT could do that.
It's a testament to how powerful these large language models are.
Right.
They're not just about generating text anymore. They're capable of some really complex thinking and decision-making.
It's really blurring the lines between different fields.
Absolutely.
It's a perfect example.
We need to explore these new applications, both for the good they can do and the potential risks they bring.
Yeah,
It's a balance.
totally. Okay, let's talk about data augmentation.
Okay, another important topic.
It's used all over in machine learning, but this paper, Armor, Shielding Unlearnable Examples Against Data Augmentation.
Okay.
It talks about how this technique, data augmentation, could have some unintended consequences.
Yeah, it's a great technique, data augmentation, for making machine learning models better.
So what's the problem?
Well, it involves making variations of the training data, like flipping or rotating images
Okay.
to expose a model to more examples. But this paper shows that it could actually mess up our efforts to protect data privacy.
Okay, now I'm confused.
Yeah, it's a little tricky.
How can something that makes machine learning better also be a privacy threat?
It comes down to these things called unlearnable examples.
Unlearnable examples.
Yeah, they're data points that have been changed in a special way to stop unauthorized training of those deep neural networks. It's like trying to scramble a secret message so only someone with the decoder ring can read it.
You're making it so AI can't understand it.
Exactly. But data augmentation, which is often used as a first step in machine learning, can accidentally undo those protections.
So it's like someone figured out how to unscramble that secret message,
That's a good way to put it.
even though it was supposed to be unreadable.
Right. So even though we're taking these steps to protect data, data augmentation could accidentally make it vulnerable again.
So it could backfire.
It could, that's the concern. But this paper also offers a solution.
The solution.
It's a new framework called Armor,
Armor.
specifically designed to protect privacy even when data augmentation is being used.
So Armor is like a shield that stops the message from being unscrambled.
Exactly. Even with those fancy data augmentation techniques.
Makes sense.
It shows how we need to think carefully about the consequences of even the most basic techniques when it comes to privacy.
Okay. This next paper sounds like something straight out of sci-fi movie. ImageNet Patch, a data set for benchmarking machine learning robustness against adversarial patches.
That does sound pretty sci-fi.
Adversarial patches, what are those? And why should we be worried?
They're one of the most fascinating and potentially dangerous threats in machine learning today.
Okay.
An adversarial patch is a change to an image, either physical or digital,
Okay.
that can trick a machine learning model into misclassifying it.
So like putting a sticker on a stop sign that makes a self-driving car think it's a speed limit sign.
That's exactly the kind of thing we're talking about.
That's scary.
It is. These patches can be used to mess with all kinds of image recognition systems.
Right.
And that could have serious consequences.
Yeah, big consequences.
So how do we protect ourselves?
Right.
First, we need to understand how they work, how effective they can be.
Okay.
And that's what this ImageNet patch is all about.
Okay.
It's a data set that's been made specifically for testing how tough our machine learning models are against these adversarial patches.
It's like a training ground for AI.
Exactly.
You're exposing them to these attacks in a safe environment
Right?
to see how well they hold up.
And that's crucial for developing AI systems that can actually withstand these attacks.
Okay, let's shift gears a bit and talk about the fundamental building blocks of digital security.
The foundations.
Exactly. Measuring complexity of signals for security applications.
Good one.
It talks about these security primitives and how to assess how strong they really are.
These are the nuts and bolts of any secure system.
Right.
We're talking things like physically unclonable functions, PUFs,
TUFs.
true random number generators, TRNGs,
Yeah.
and pseudo-random number generators, PRNGs.
It's a lot of acronyms.
It is, but they're used in everything from cryptography to hardware authentication.
Okay, I'm going to need a little more explanation on those.
So imagine you need a unique ID for your device, something that can't be copied or forged.
Okay.
That's where a PUF comes in.
Okay.
It's like a digital fingerprint for your hardware.
Makes sense.
TRNGs, they're all about making truly random numbers, which are crucial for cryptography.
Yeah.
PRNGs, on the other hand, they make numbers that look random, but are actually determined by an algorithm.
Okay, so they're all about making things random.
Exactly.
And unpredictability is key for security.
Absolutely.
So how do we know if these primitives are actually secure?
Good question. This paper introduces a new way to figure that out. It's called dysentropy of autocorrelation.
Dysentropy of autocorrelation. Wow.
It basically measures how much order and predictability there is in the signals these primitives generate.
So it's like a quality control check for security building blocks.
Exactly. Making sure they're strong and can resist attacks.
That's good. We want them to be strong.
We do. And this new method could help us design better security primitives, make sure the foundation of our digital world is solid.
Makes sense.
Really important stuff.
Absolutely. Okay, let's wrap up this batch of papers with one that deals with a classic dilemma: balancing advertising money with user privacy.
Always a tough balance.
It is.
Yeah.
Ads BPC, click measurement for online advertising via per-user differential privacy.
Okay, I'm listening.
It's a new system called Ads BPC that wants to protect user privacy while still letting advertisers see if their ads are working.
The best of both worlds.
How does it pull that off?
It uses this technique called per-user differential privacy.
Okay.
Basically, it adds noise to each user's data
Okay.
in a way that protects privacy but still allows for overall analysis.
So you blur the details but keep the big picture.
Exactly. Advertisers can still see how their ads are doing overall, but they can't tie that data to a specific person.
Okay, so no more trashing individuals.
That's the idea.
I like that.
It's a promising step towards making online advertising more privacy-friendly.
All right, so that wraps up this first set of papers.
That was a lot.
It was.
A lot of interesting research.
It's clear that this whole world of cybersecurity and privacy,
Yeah,
it's constantly changing.
absolutely.
But it's encouraging to see so many researchers trying to keep us safe in this digital age.
For sure. Lots of brilliant minds working on this stuff.
Yeah. And as we go through the rest of our deep dive, we're going to see even more cutting-edge research
Can't wait.
shaping the future of technology.
That's going to be exciting.
All right, we're back, ready to dive into more of this cutting-edge research on cybersecurity and privacy. It's wild how many different areas these papers cover. We've seen AI being used for everything, protecting LLMs to catching phishing attacks. What's up next?
Well, let's stick with the AI theme for a sec.
Hmm.
This next paper, MetaUA, a meta-learning scheme for user-level network traffic anomaly detection, is all about spotting those weird things happening in network traffic, but with a really cool twist.
A twist. Okay, you got my attention. Tell me more.
Imagine you're training, like a security guard, right,
Okay.
to spot shady behavior.
Right.
You can show them examples, someone trying to break in, acting
Right.
nervous.
Suspicious stuff.
But what happens when a brand new threat pops up? Something they've never even seen before.
Uh-oh. Not good.
Right. And that's a big problem with the way we do anomaly detection now.
They're good with the known threats.
Yeah.
But
Yeah, they're great at what they know.
when something new comes along,
Yeah, new patterns, they struggle.
so how do we train our security guard or our AI system to be more, I don't know, flexible?
That's where meta learning comes in. It's training AI to, learn how to learn.
Okay.
Instead of just memorizing patterns, they learn to generalize from what they've seen before so they can adapt to these new situations.
So it's like giving them a mental toolbox so
Exactly.
they can build their own solutions to new problems.
You got it. And that's what this meta UA does.
Okay.
It uses that meta learning to train a model to find anomalies in network traffic, even if it's something totally new.
That's huge, especially when the cyber threats are changing all the time.
Yeah, it's a powerful tool to have in your security arsenal.
For sure. Okay, let's talk about data analysis. The paper Primo, Private Regression in Multiple Outcomes, dives into privacy risks when you do multiple regressions on the same data. Can you remind me what regression analysis is all about? It's been a while.
Of course. Regression analysis is a statistical way to understand how different variables are related, like how age and income are connected, or exercise and heart health.
Right, I kind of remember that from stats class.
Yeah.
But what's the privacy issue?
Imagine a researcher looking at genetics and different health outcomes.
Oh,
They
yeah.
might do multiple regressions on the same genetic data, looking at, say, heart disease risk, diabetes risk, even cancer risk.
So the genetic data is the same, but they're looking at different outcomes.
Exactly. And there's the privacy risk. Even if they're only sharing the overall statistics, someone could use those to figure out sensitive stuff about the people in that data set.
It's like those stats, even if they seem harmless, could be pieced together to reveal private information.
Exactly. But this paper offers a solution. It's called PRIMO, stands for Private Regression in Multiple Outcomes. It's designed to protect privacy in this exact scenario.
So it makes it harder to leak personal info when you're doing these multiple regressions.
You got it. It's adding a layer of protection to those analyses.
Okay, so even with anonymized data, we still got to think about privacy.
Absolutely. Privacy should always be top of mind.
All right, let's switch gears and talk about this new approach to machine learning, vertical federated learning, or VFL.
VFL, yeah, interesting stuff.
The paper UIFV, Data Reconstruction Attack in Vertical Federated Learning. Sounds like there might be a weakness in this tech.
VFL is a cool idea, right?
It is, it is.
It lets different groups work together on a machine learning model without actually sharing their raw data.
Right, so it's great for privacy because you're not exposing all your sensitive info.
Exactly. It's like baking a cake together. Everyone brings their own ingredients, but they only share the final product.
I like that analogy. Makes sense.
But this paper, it shows a potential catch.
The catch, meaning.
They found a new attack, UIFE, that can rebuild the original private data just from the intermediate stuff that gets shared during the process.
So even though the raw data isn't fully shared, someone could still figure it out.
That's right. It's like someone tasting the cake and figuring out the recipe from the different flavors.
Wow, that's sneaky.
It is, and it shows that even these secure systems can have hidden weaknesses.
So we always got to be on the lookout for new vulnerabilities.
Absolutely. Never let your guard down in cybersecurity.
Okay, for our final paper in this section, let's head back to the quantum realm, towards a hybrid quantum differential privacy.
Quantum again, back to the future.
It looks at how quantum computing and data privacy, how they work together.
It's a complex relationship.
Quantum computers, they're those super powerful machines
Yeah,
that can solve certain problems way faster than regular computers.
light years ahead.
Right. But they could also be a threat to privacy because they could break all the encryption we use today.
Exactly. It's a double-edged sword, that's for sure.
On one hand, quantum computing could change everything.
Absolutely.
But on the other hand, it could wreck digital security as we know it.
It's a balancing act. This paper is looking at how we can actually use the unique stuff about quantum systems to make privacy stronger.
So we're using quantum to protect our data,
Yeah.
even though it could be used to break our current security.
That's the idea.
Okay, my mind is blown.
It's wild, right? The paper talks about hybrid quantum differential privacy.
Okay.
It uses both the computing power and the randomness of quantum systems to give us really strong privacy.
So we're harnessing the power of quantum
Exact.
to create and solve problems at the same time.
That's a great way to put it. This is early research,
Yeah.
but it shows how quantum is going to be a big part of data privacy in the future.
Wow. That was a wild ride through some seriously mind-blowing research.
It was a lot to take in.
From AI that can spot anomalies to quantum privacy, it's clear that cybersecurity and privacy, they're going to be anything but boring.
It's an exciting time to be working in this field.
And we're just scratching the surface of what's possible.
Absolutely. As these technologies get better, we're going to see even more creative ways to protect our digital world.
It's going to be an interesting journey.
It's going to be wild.
We're back for the final part of our deep dive into all this amazing cybersecurity and privacy research. It's incredible how researchers are coming up with new ways to keep our data and systems safe. What else is out there?
Well, we've talked a lot about AI and quantum, but let's not forget those good old-fashioned attacks that target humans, not machines.
No.
You know, like social engineering.
Social engineering,
Mhm.
where they try to trick people into giving up sensitive info.
Exactly. It's one of the oldest tricks in the book, but it still works.
Yeah, people can be the weakest link sometimes.
This paper, Measuring Complexity of Signals for Security Applications, looks at how to make our security systems tougher to manipulate.
Okay, tougher to manipulate. How so?
It focuses on those security primitives we talked about earlier, like PUFs, TRNGs, PRNGs. Remember?
Yeah, they're like the foundation of secure systems.
Yeah,
Used in everything.
right. This paper introduces a new way to evaluate how resistant they are to manipulation. It's called dysentropy of autocorrelation.
Dysentropy of autocorrelation. That's a mouthful.
It is. Basically, it measures how complex and random the signals generated by these primitives are.
So the more complex the signal, the harder it is to mess with it?
Exactly. It's like trying to pick a lock that keeps changing its shape.
Okay, that makes sense.
This new method could help us build tougher security primitives, so they're way harder to exploit.
That sounds like a big win for security. All right, let's wrap things up with one last paper. This one's about that classic challenge balancing how companies make money from advertising with user privacy.
Always a tough one.
Ads BPC. Click measurement for online advertising via per-user differential privacy.
This one's about a new system called Ads BPC. It tries to protect user privacy while still letting advertisers see if those ads are actually working. Win-win, right?
Win-win sounds good to me, but how does it work?
They use a technique called per-user differential privacy. It adds noise to individual data in a way that keeps things private, but still allows for that big picture analysis.
So it's like hiding the individual details, but keeping the overall picture intact.
Exactly. Advertisers can see how their ads are performing overall, but they can't connect it back to a specific user.
So no more tracking individuals.
That's the goal.
I like that. It seems like a good step toward making online advertising more privacy-friendly.
It really does.
Well, we've covered a lot today, from AI attacks and defenses to the whole world of data privacy in this quantum age. It seems like we're in this time of incredible innovation, but also a lot of risk.
It's like building the airplane while you're flying it, right?
Yeah, that's a good way to put it.
We're creating these amazing technologies, but we're still learning how to use them safely.
Out of all these papers, what were the biggest takeaways for you? What should our listeners remember?
I think the biggest thing is awareness. You know, be aware of the risks. Stay up to date on what's happening. Ask questions about how your data is being used and protected.
So be an informed digital citizen.
Exactly. Knowledge is power. The more we understand these technologies, the better we'll be at handling the challenges and opportunities they create.
Couldn't have said it better myself. Thanks for joining me on this deep dive into the world of cybersecurity and privacy. It's been a fascinating journey.
My pleasure. To all our listeners out there, stay curious, stay safe, and keep on exploring.
And remember, the future of tech is in our hands. Let's make it a good one.